Hola. Bueno, primero agradeceros a todos vuestra asistencia.
Good afternoon. I'd like to thank you all for attending this roundtable. We're going to open a roundtable dealing with machinery, failure, and security and turbines for energy generation. I'm going to be very, very brief in introducing the panelists because we really want to focus on their presentations. I'm going to briefly introduce you to the four speakers or panelists. We have excellent representatives of the main stakeholders that play an important role in power generation. We have a representative from engineering, from operations of plants. We have a technology representative. And I hope you find this roundtable interesting and insightful, and I hope it encourages members of the audience to ask questions and make comments. I'm sure that we'll all enjoy and learn very much from this roundtable. To my left, I have Francisco Javier Lacalle. He is here in representation of Tecnatom. He holds a degree in industrial chemistry, and he has worked for more than 23 years in the world of generation, more specifically the engineering thereof. He has worked in different kinds of plants, thermal, nuclear plants, and during the past 4 years, he has been working in Tecnatom. He is in charge of energy and industry of Tecnatom, and he will be the first speaker. Secondly, we will have the pleasure and the honor to listen Santiago Garcia. He holds a degree in chemical science as well, holds a master in business administration. He has worn many different hats. He's a trainer, a writer. He has worked in ops and maintenance in power plants. He was in charge of the first combined cycle plant that was built here in Spain. I'm sure we're going to enjoy his presentation very much as well. Thirdly, we will listen to Daniel Elias, who is here on behalf of Iberdrola. And Daniel, let me check my notes on my mobile phone. I'm afraid I didn't have time to study your CV as I should. He is in charge of maintenance for the northern region of thermal generation in Iberdrola. He has broad experience in maintenance and operation of thermal plants. And he has been the maintenance manager and the ops manager in several plants since the year 2000. Santurce, Pasajes. He also worked in Longinet in Scotland. And he is currently in charge of maintenance for combined cycle in the northern region of Spain. Thanks very much for joining us as well. And last but not least, we're going to listen from the point of view of the providers, the vendors, the technology experts. Our last speaker is here in representation of Siemens. He works in the division that develops large-scale turbines. His name is Falk Aserman, project manager for first-time application and product commercialization of gas turbine service products. He will deliver his presentation in English. He has worked in Siemens for many years. He has held different positions, and during the past year, he has focused on the new technologies for the development of new turbines. And I wanted to be brief in these introductions because I think that it's time for us to listen to the panelists. And I think that their presentations are going to complete what Pedro Soria exposed earlier. Good morning, ladies and gentlemen. Thanks very much, Mafre, for inviting me to participate in this seminar. I don't want to bore you. I'll try to be short and sweet. My presentation is divided into 5 parts. I'll give you a brief introduction, and I'm going to refer to some of the technical conclusions that Pedro Soria referred to earlier during his opening presentation. Second, I'll talk about degradation phenomena in steam turbine. I'll share with you some examples of incidents in steam turbines. And I'll try to explain why gas turbines are exposed to a higher incident rate than steam turbines. And I'll try to compare the gas and the steam turbines to explain that. And last, I'll talk about degradation or wear phenomena in gas turbines. I know that Santiago Garcia will address more practical issues pertaining to the maintenance of turbines. I'm going to be a bit more general in my approach. Let me start with the background information. If we analyze the conclusions of the study presented by MAFRE, and we focus on two main issues, we see that there's a relatively high incident rate of turbines if compared to other generation equipment. In the case of gas turbines, the accident or incident rate is higher than that of steam turbines, and this is perfectly logical. Gas turbines operate at more demanding conditions as opposed to steam turbines. During the 90s, there was a vertiginous race to increase the yield and the performance of gas turbines. And we have technology experts and vendors in the room. And if I may say, perhaps at that time, some turbines were sold and commercialized with insufficient operation hours. We had the challenge of reaching 60% yield in combined cycle, and the conditions in which the turbines operated were extremely demanding. The elements that have suffered most and that have caused a greater number of incidents are the blades. Later on, I'll explain to you the different degradation phenomena that affect the blades in gas turbines. In the case of steam turbines, the incident rate is lower, and this is due to errors in or failures in control and regulation elements. This is also quite understandable. The gas turbines have suffered problems as a result of degradation of blades, as a result of the very extreme circumstances and the number of startups and shutdowns that they need to face. In the Spanish territory, we have 102,000 megawatts of installed capacity, and the power peak in 2014 was 40,000 megawatts. This means that the time of the day with greatest consumption involved an output of 40,000 megawatts out of the 102,000 megawatts of installed capacity. As you can imagine, this means that due to a series of technical restraints of our grid, we have some combined cycle plants that are starting up and shutting down virtually every day. As for the main failures in steam turbines, most of these failures have to do with the control and regulation elements. This is very logical as well. It's true that the system is much less rigid than in gas turbines. is more difficult to make an operations mistake. In the gas turbines that are started up with sequencers, there are many backups and redundancies and safeguard mechanisms that are in place. So it's hard to make a human error in the case of gas turbines. In the case of steam turbines, the supervision during startup is done not by an automated system but by operations staff. Regarding technology, we often say that the conventional thermal power plant performance is relatively good. We have an average performance of those plants that use gas turbines. In the case of biomass plants and solar thermal plants, the level of performance is worse. I think this is due to several aspects or several reasons. First of which cannot be well influenced on conventional thermal power plants. When they start up, they operate in a more stable manner. They are exposed to less load variations, to a lower number of startup and shutdowns. In the case of gas and thermal solar plants, the number of startups and shutdowns is much greater. However, there's a second factor or element that leads to greater incident rate in the plants. And I think that engineering companies can influence on this second factor, as well as the training companies. From our point of view, the operations staff of conventional thermal power plants who have accumulated long hours of operation, and they are perhaps more highly qualified than the operations staff in other more recent plans. And now let me refer to those systems that exist to subsidize or to assist operation. In Spain, we see that most of the plants have control systems based on a limited number of alarms. And this allows us to supervise and monitor operation pretty easily. If we go to a coal plant, we have perhaps a few hundreds of alarms in place. However, much to the contrary, in some combined cycle plants, we have 15,000 alarm signals. 15,000 alarm signals. And probably we have 10, 20 alarms that pop up every minute or every 2 minutes. So this means that we have an operator that doesn't have enough time to analyze what is happening in the plant, that has to deal with a huge number of alarms. It's very hard to manage. Some years ago, when the coal plants were installed, placing alarms was expensive. You had to lay cable, have some space reserved on the screen. But now what is expensive is to remove the alarms. The vendors of the equipment believe that all the signs can have the category or the status of alarms. Sometimes for servers air instruments, we have 125 alarm signs. And this means that we need to devote many man-hours to handle that. So this means that what is expensive is to have a limited number of alarms, which is a situation contrary to what happened in the past. I'd also like to insist on the operations manual. The combined cycle plants, perhaps to a lesser extent, but the biomass and solar thermal plants often lack an operations manual, at least many of them. So this translates into the fact that the plants aren't appropriately managed, are not managed to the best standards. Sometimes operations depends on the criterion of the shift manager that is in charge at the time. So there is less rigor. Well, after this brief introduction, I'm going to refer to the degradation phenomena in steam turbines, then in gas turbines, and I'll show you some examples of wear and degradations in both gas and steam turbines. I'm going to devote very little time to this section. My colleagues will focus on this with greater detail, so I'm just going to run through it. The main causes of degradation in gas turbines are fatigue phenomena, both in low cycle and in high cycle, i.e. thermal origin tensions produced during startup. Then we also have the high cycle fatigue, stress corrosion cracking. We also have identified erosion corrosion phenomenon, the weakening of material or fretting. If we take a look at really understanding, if we try to understand each of these phenomena, we see that in the case of low cycle fatigue, this low cycle fatigue can be defined as the gradual damage or degradation of a material produced as a result of the subsequent heating and cooling cycles that translate into expansion and contraction of a material. There is a plastic deformation, and this thermal fatigue occurs mostly during startups, outages, shutdowns, and load variations. In the case of the heat turbines, not all the plants have the mechanisms in place to control the cooling rate when the plant is shut down. Sometimes the managers are in a hurry to restart the plants, and this leads to fatigue. In the case of high cycle fatigue, most of these cases are caused by vibrations. Here we have identified the critical areas that are most exposed or vulnerable to fatigue: the high pressure rotor. And we're basically referring to the bore of the turbine, and the low pressure rotor. We have a low cycle fatigue with resonance in startups and shutdowns. Then we have the mobile blades. We also find that bearings and the rotor are also very vulnerable to fatigue. I'm sure in my presentation will be uploaded on the website, so you can take a look at the details later on. I'm going to run through it now. We take a look at the third degradation phenomena. It's SCC, or stress corrosion cracking, that occurs when there's a combined action of a corrosive agent, polluted moist steam, and a mechanical effort. And at this point, I'd like to clarify something which isn't specified here in my presentation, which is the fact that often stress corrosion cracking is caused as a result of the steam becoming polluted, as a result of the fact that in many power plants the control systems aren't well adjusted. The steam temperatures aren't well adjusted. This prevents the
steam to go higher than 50-30, for which the turbines are designed. Sometimes the steam raises higher in temperature, and quite often we have plants where for hours they've got to work with these tempering devices opened. You usually inject pulverized or sprayed water in the main steam lines, and this sprayed water might have more or less solid particles than the steam itself in the steam turbine. And this, from a running point of view, we might prevent the unnecessary use of these temperature controller devices. So usually when there are these changes, we usually might see small cracks, and the efforts related to this operation, the creation of these cracks might be not very severe. It might be related to the state of the turbine, and we usually find many data, because in the States we see that after certain surveys, whenever there have been some failures due to corrosion under tension, this has led to disaster. Sometimes even it's led to fatalities, to the loss of human lives. Okay, I'm going to skip these CCs because we're going to see this in another presentation. And then we've got other degrading phenomena like erosion for corrosion. This might be related to the absorption of hydrogen. Then we've got fretting of wearing out. And then we've got some of the specific parameters of this degradation, like the average of temperatures, the drop of pressure and the performance. We might see some vibrations, and we might also see problems with the lubricants. These are the periodical inspections that of the turbines, and then the N and Ds that we've got to implement, and then also the magnetic particles, the X-rays, and so on and so forth. And then also we see here how we can analyze the whole of the turbine to see what the remaining life is and the inspecting period advised is. And then we've got the main mechanism of mitigation, which is common sense, to optimize the number of shutdowns and startups, then to do a preheating of the turbine, to study the critical speeds, to avoid situations in the condenser, and to reduce as much as possible the vibration. Then we have some examples of some turbine incidents. Here there was a failure in this steam turbine because it was not coupled, and when they were going to undertake the overspeed test, well, it didn't work properly. There you see the low pressure elements, how they're before and after. There was a fire in the high pressure element. There you can appreciate what the shaft coupling looked like after that incident. Then we have another example here. The turbine ran out of lubricant oil, and there you see there was on the first picture that you see how that element got broken because the bearing was fretting against that element that got broken finally. And then you see what the shell looked like. Then the coupling of the turbine with the generator. Then there was a fire, and you can even appreciate the hole in the roof of the premises. And it seems that part of the turbine had to was propelled through the roof. Well, they were using steam, a very good steam, demineralized as work fluid with the right pH and the right level of oxygen. And We used also atmospheric air, and we've been adding to it some fuel. Then this fuel and this air might have some salt, some sediments, sodium, vanadium, and then also there is a power control done to see whether the inlet temperature at the turbine is proper. So sometimes it suffers from some thermal tension, and then we work with temperatures that go up to 1,200, and this leads to having sophisticated cooling systems. And then finally, yes, a short review of the degrading phenomena that happen in the gas turbines, like creep burning, hot corrosion, fatigue erosion, and impact. And then since I'm running out of time, I'm just going to show to you some of the results in these pictures of these phenomena like creep. Here we have this case of creeping. The gases from the turbine, they expand, they're not homogenized, and there's a very high profile of temperature. There you see how they were too hot in one area. Here we see an example of burning. And then, when we talk about corrosion, simply I want to mention that it is especially critical in the in islands, because they use gasoline, and it might have sulfur, vanadium, potassium, so it might be polluted. Then we've got here two charts in which we appreciate how, if we increase the PPTs of potassium and vanadium, it changes, and then the life expectancy of the blades might reduce up to a 10%. Then same goes for the chamber. Then when we see these cases of fatigue or wearing, we see how the blades lose their original shape, and also how they might get damaged due to this fatigue. Then erosion due to some acids, and we see how the outside layer was fully destroyed, and then some problems of impactions. So I guess I've been able, or I hope I've been able to share with you the content of my presentation. And should you have any further doubts or comments, I'll be eager to answer them during the Q&A. And also for the audience to know that the whole of the presentation can be downloaded from the website. So without any further ado, I'm going to give the floor to Santiago Garcia. He's the technical manager of Renovatec. He's going to talk about maintenance.
Bueno, buenos días a todos.
Well, good morning, ladies and gentlemen. First of all, congratulations, Pedro, on your presentation. I mean, I don't know what else I could add, because some of the conclusions were something that we were not really expected, even though I work in this field, and I should have kind of very good information, but it does not match your information. So I guess you're working with a larger sample, and that leads to some conclusions which are not the conclusions I was expecting. I am impressed by how these valves, regulation valves, are responsible for such a large part of these incidents, and also how it seems that, according to the comments in the insurance field, it is very well known that after intervention, the possibility of having an incident is still very high. The all mechanicians used to say, well, if something works, do not touch it. And it seems this is the same conclusion as Pedro's. So I hope we will later on be able to dwell on it. Well, my name is Santiago Garcia. I am the technical manager of Renovotech. We basically work in the field of energy, and we also do industrial maintenance. One of my activities is the survey of incidents or failure that will have an impact on lawyers or insurance companies or on the premises owners. We also do training and other activities. I am an expert on turbines. I'm not just a small expert. No, I am the expert on turbines. And I've got to say it because I went wrong so often that I can now say that if anything could go wrong, I've seen it and I've done it. So this is why I'm an expert with a capital E nowadays. So, I mean, this is fruit of practice. I bet you. I mean, I can really tell you. Unfortunately, I am an expert through experience. And since I only have 20 minutes to talk to you, I've got to focus on something, and I wanted to sort of provide you some sort of practical message. I don't want to talk about sort of theoretical things because you know about them. So I wanted to focus on some aspects to sort of give you an inside view. And whenever we talk about turbines, design is very important, as our colleague from Technoturn said. Many turbines have been implemented without really very sophisticated design. Sometimes also some of the operators, especially now with the new emerging technologies or new technologies, there are many operators that did not know this field. They came from another field and they've been hired simply because they're very close to the premises, not because they are very good as technicians. And this is how we usually call them sort of the neighbors that give up on their favorite hobby and decide to do this. So, I mean, we've got to sort of brief them on some of the concepts which are of paramount importance for this kind of operations. I'm not going to sort of get into every detail about how the fact of not running properly the premises might be the cause of some of the incidents. I'm going to talk about the maintenance policies because they are, on a large part, responsible of most of the incidents in a turbine. Okay, let's talk about the current scenario. The current scenario is that we have, as Francisco said, a power which is smaller in the plants. Many powers only run for some few hours, and the pool prices are low. So we have like an overcapacity. So we used to have 180,000 megawatts installed, and since they're no longer that profitable, we've got to make them run for a shorter time. And we, given this scenario, we try to cut down on cost, and one of the costs is precisely maintenance. And you can reduce the cost of running your premise, but the thing is there are some maintenance expenses that could be reduced, because reducing that is just reducing not very important things. It's like removing the fat out of your body, not touching your muscles. But, I mean, at a certain point, you are removing fat, but if you keep on cutting down on cost, you end up touching your muscles or the muscles of these installations as well. And there's been such a cut in the maintenance budget that this is leading to failures, to lack of availability of people and equipment. And this leads to the fact that maybe in the coming years we're going to see an increase in the incident rate related to this cut in maintenance. So cutting down the maintenance budget has got mainly three repercussions. So that is liability, availability, and the maintenance cost might go down as well, and also the life cycle also might become shorter. So it will be running for fewer hours, so it will not be available that often. The cost of maintenance, even though initially we might consider cutting it down, we will end up with an increase of the maintenance because the life cycle or the lifespan of a plant is going to become shorter. So this happens if we cut maintenance budget without doing it properly. So we can face this situation without having a negative impact on availability, liability, cost of maintenance, lifespan of the premises, and without running the risk of having a failure. We can do it. The answer to this question, can we do this? Yes, is yes, but we've got to do it properly. We are working more than 50 hours all over Spain, and we're there somehow, some as advisors, some we develop the maintenance plan or scheme. Sometimes we intervene whenever there's an incident. Sometimes we do training for their staff. So we have quite a large population or sample to know where the cuts are happening. And we think that we can make cuts on maintenance, but you've got to do it properly. So we might go for cuts in staff, in the maintenance plan, in the outsourcing policy, in the spare parts policy, in the software tools that we use to manage maintenance, in non-operational managerial tools, and later on we'll let you know what this means exactly. And then we've got to also maybe do audits. That is, we do a benchmark with other premises. Well, talking about staff, what do we need nowadays? And this slide is thought for Europe. It does not concern so much South America or Africa, which are the markets that we know, because we do not know much about the Asian market. But this slide concerns rather Europe, where there is less of a demand of a staff in the premises, but that means also that the people they need, they want them to be people with a higher qualification. And the people that should then be working in this power plant should be more polyvalent and know better how the installations work. Then we can also cut on maintenance. But that implies some changes, and I'm glad that this slide doesn't contradict what Pedro said, because I swear we did not reach any agreement, but this sort of confirms what Pedro says somehow. Well, there is a right percentage of preventive maintenance. This might be like an 80%, what is the preventive and the corrective. It should be maybe the ratio 80-20. If you reduce preventive maintenance to improve the hours load, it is an error. If you reduce preventive maintenance, that you're going to increase the corrective maintenance cost. Some plants might think if we reduce the corrective, if that additional cost is taken up on board by an insurance company, well, that might be right, but I don't think insurance companies sort of pay all this, and they especially pay attention to not paying for what they should be liable. So, to reassess the maintenance scheme of a plant, we should give less of an importance to the systematic maintenance of a plant. There we set a number of hours, and this is not the optimal kind of plan. Sometimes we replace some parts that have not reached their end of cycle. Sometimes it is an error to consider that we've got to replace blades or the combustion chamber after a certain amount of hours. There are other ways to do this, and there are other criteria to use, which are not only the hours. And this should be redefined by the manufacturers. So what is a better policy? Not to talk about running hours, but rather running conditions. Nowadays, it is more interesting and is going to cut your costs to see what conditions your elements are at and replace them when necessary, rather than when just a certain formula says that you've got to replace them. And I think when we do a new maintenance plan, we've got to sort of shift towards this state of the parts rather than focusing on the running hours of a part. We've got to adapt better this maintenance plan to the existing conditions in a certain premise by using the reliability central maintenance, which will assess the potential failures that might happen in a plant and then considers a plan according to that RCM and not according to the manufacturer's instructions. We are quite critical to the manufacturers regarding the manufacturer's instructions because sometimes they've got a small pump and they think you've got to sort of remove it every month and change the bearings every week. And some other manufacturers, they have larger or more important equipment, and according to their manuals, they say, yes, like keep an eye on it every 5,000 hours and then contact our service, technical service, to undertake this maintenance review. So we consider that often the manufacturers do not know exactly when we should review these parts. And this can be done with the means that the main utilities have, like Iberdrola and others. And even some smaller companies could do it. The other thing you need to do that is the right technicians to do it. We can also try to reduce the cost of outsourcing. Large part of maintenance in plants is outsourced. Hiring other companies for a time was like a trend, a very common trend. And outsourcing maintenance, one based on the fact that it was cheaper to hire people outside the company than working with your own staff. Nowadays, it is not the case because according to the new bargaining agreements, the fee is exactly almost the same. And some of the activities have to keep on being outsourced because you do not have the right tooling or knowledge or spare parts to do them. But some are only outsourced because the power plant maintenance people are only used to be sort of the managers. And they say, I'm not going to touch on it. I'm not going to do a hands-on work, but rather, yes, like sort of I'm going to survey what I outsource. So we're going to outsource because we don't have the knowledge or the means to do it. But then it is the workers of the plant themselves that will have to undertake these activities. And it doesn't mean that we're reducing the quality of the maintenance, but only the cost of it. And then spare parts policy. Well, there's a lot that we can gain here. Not too far ago, for every euro invested in, or for every 2 euros, he corrects, invested in labor, we would spend €1 in materials. When we're working with high technology, usually in this kind of plants, spare parts no longer mean a third of the maintenance. They mean much more. They mean more than half of the maintenance cost. Basically, it is spare parts that you pay for, because manufacturers, they have found a very profitable way to sell their spare parts. For them, selling spare parts is more profitable than selling to you the machine itself. They might give these, they might as well give these machines away to you, provided you buy from them the spare parts. And usually the machine manufacturers are not the manufacturers of the spare parts. Often what they are integrators, so what they put into their machines, and we're talking about blades and bearings and instruments, all that is bought by the manufacturers to an external supplier. So if we want to cut down the cost of maintenance, you've got to find that supplier and buy directly from that supplier of spare parts. Then, in such a way, you're going to reduce the cost of the maintenance without compromising the efficiency of the maintenance that we are undertaking. So we're going to have the real good spare parts. We might also have to remove useless expenditure, like the software we use to manage maintenance. Often we see software that are hindering maintenance. They become sort of an obstacle that you've got to overcome to finally or effectively do maintenance. And a good example will be SAP. I know they've got a module for maintenance, and I guess the person that invented this software was well intended, but it is very extended. It costs lots of money, but at the end of the day, it's very difficult to use. So maybe we should shift to another software. And in many places, they end up managing maintenance with an Word software or with an Excel software rather than with a SAP software. So we might go for a cheaper and simpler software that ends up being a help, an aid, rather than an obstacle. Okay, things to avoid to cut down your cost. Well, some certificates and laws that sort of contribute nothing to your company. I don't know if the person that invented the ISO sort of drinks too much or what. I'm not an expert in this certificate. Maybe he was very well intended, but unfortunately, when I see this being implemented, this is nothing but red taping that only leads to additional work. And the day I see that the ISO 9001 says, well, you now have two people, you should have one, or when you have this storehouse, you should have a larger storehouse or a smaller one. Up until that day, I think this only means an expense. So what can we do best with this ISO 9001? Well, up to you. So, undertaking audits. Audits, well, let us know where we are failing, where we are not very good at, where we are moving away from the standards of excellence. Well, you've got lots of literature to find where to define your standards. We've defined ours, and then we audit them according to different standards that you might take into account, which are real audits. They are not audits like done by these kind of quality, so to say, systems, and they try to really know or indicate where we're removing or moving away from the right parameters. Okay, so this might be helpful. Conclusions. We electrical plants have to reduce the money they spend in maintenance. This is not just because the financial manager wants so. It is rather because either you do it or you are out of the market. Can we cut down the cost without having an impact on the result? If you do it because the financial guy tells you, okay, just cut it down by 20%, that might lead to a total disaster, because then somebody might be responsible for what they are telling us to do without really knowing what to do. And by this somebody, I mean maybe the insurance company. And the keys to this reduction might be 7. Cutting down on staff, new maintenance scheme, new policy of outsourcing, new uses of managerial tools, new softwares, new spare parts policy, and new audits.
Muchas gracias, Santiago.
Okay, thank you very much, Santiago. As usual, very, very interesting. Now we're going to give the floor to Manuel Elias, who's going to give us the point of view of somebody that really runs and operates a plant. So, Daniel, you've got the floor. Well, good morning, everybody. My name is Daniel Elias, and you all know, and as Alejandro has said, I've been always in my career working in maintenance and running of thermal plants. I began working in the fuel oil plants, the traditional thermal plants, and I've been working here and in the United Kingdom. And now I work in the field of cycles, combined cycles plants. So I share fully some of the messages that Santiago mentioned, that we've got to go for predictive maintenance. And then I really like what he said, that is moving back to having the plant staff doing maintenance again. This is sort of the contrary to the outsourcing trend that we saw some years ago. So somehow, with my presentation, I would like to comment how at Iberdrola and thermal plants, the thermal plants, we've been sort of assisting to these 5 years, especially the last 3 years, where we've seen an impact of the downturn, financial downturn in the generation business.
Bueno, voy a empezar un poco hablando de lo que es un poco el entorno de negocio.
I'm going to explain to you the business environment. For you to understand, we find ourselves in a scenario during the past 5 years, and particularly the last 3 years, in which there has been a sharp drop in the operation hours. I'm going to explain this to you in detail, breaking it down by technologies. And there are 3 factors that have led to a reduction in output. On the one hand, the decrease in the demand of a power supply associated to the economic downturn. Second, this is due to the strong penetration of renewable energies during the past years. And thirdly, as a result of, as Francisco was saying earlier and Santiago mentioned, the overcapacity of our system. As a result of the economic recession and the strong increase of capacity in renewables, we found ourselves in a scenario of overcapacity, and this has had a very strong impact on thermal generation. Why? Well, because thermal generation is the last to join the market. It defines the prices in the spot market, and it has been more severely hit during these years of economic crisis. This, of course, urged us to adopt a series of measures that I will explain during my presentation. Many fuel, oil, and gas power plants were closed. Combined cycles plants were also closed, many of them. And we have understood that we had to upgrade efficiency and operating management. We've lived in a scenario of lower investments, and we've moved towards a more flexible operation. The market is demanding greater flexibility. In terms of output or production, Iberdrola, for example, in the year 2009, produced in Spain 20 terawatts-hour with thermal generation, and in 2014, this amount has been of 3.3 terawatts-hour. So we're talking about a decrease that it multiplies by 6 the previous that is 1/6 of the level in 2009. So a very, very sharp drop. Here we have a slide that illustrates thermal generation production. You have a pie chart. There you can see that coal plants accounted for only 4% in 2014. Here you have the figures also for 2013. There's a strong penetration of renewable energies, hydro, and nuclear energy as well. So let me focus now on the different technologies. Fuel, oil, and gas conventional power plants. Let's address this technology first. Prior to the crisis, these plants were like a reserve for the system, and they were connected to the grid during peaks in demand. And whenever there were restraints associated to the maintenance of lines, they were disconnected from the grid. And that's why there was the power guarantee mechanism in place to make them profitable. Due to the overcapacity scenario that later on emerged, well, these power plants were no longer profitable, so it was decided to shut them down and to decommission them. In the case of Iberdrola, and I think other companies did the same. Iberdrola has either dismantled and decommissioned or fully the plants, or is in process of doing so. Here we have the combined cycle power plant of Santurce on the same site where Iberdrola used to have 2 units of conventional fuel, oil, and gas power plants. Now, as you can see on the picture, these 2 units have been removed, and now we have a combined cycle plant. From the point of view of combined cycle plants, which probably interests you most, together with coal, I'd like to mention that this is a technology that is pretty young. We're talking about startups between 2002 and 2008, and during a period of 12 or 10 or 12 or 8 years of operation in total. So there's already some experience and some maturity in the ops and maintenance of the combined cycle plants. And what we have seen is that the decrease in production and in operation hours has been very, very sharp. And this has forced some first-generation combined cycle power plants that were less efficient to second-generation combined cycle power plants had to stop their activities. And they have been put to conservation. I'll explain to you this concept later on. And a series of efficiency and flexibility measures have been implemented in order to maintain reliability and safety. What's the conservation of combined cycle power plants about? The idea is to conserve or preserve the facilities from the point of view of corrosion and the best possible conditions. So what is done is to have the major equipment, the recovery boiler and the gas and the steam turbine in atmospheres that minimize the effect of corrosion. We're talking about dry air at the end of the day and nitrogen atmospheres. But it's also important to highlight that these plants are available for the grid. This means that if needed, they're going to start up. And the only element that distinguishes them from the plants that are in operation is the fact that the startup times are longer, because in case they are requested to join the grid, of course, the circuits need to be filled up. From the point of view of business, of course, this doesn't make much sense in the short run, but it does in the mid and long term. For Iberdrola, the idea, considering the forecast for the upcoming years, is that these combined cycle plants will be connected to the grid as prior to the crisis. And if the forecasts are confirmed, well, these plants will be in operation. As for the efficiency measures that have been put into place, there has been a geographic restructuring following the model followed by Iberdrola in the hydro production, and we've set a new management model that is based on regions. And as Santiago has mentioned, we have also reduced outsourcing or subcontracting. In the past, most of the maintenance had been outsourced, and the crisis has forced us to bring maintenance back to the plants on site. So it is now assumed by in-house staff. Iberdrola is following this trend as well, this in-sourcing. And this in itself is also a challenge. It's not easy, not at all. Because we have some workers that have worked for a long time in our plants, and now we have new generations, and the different generations have different skills, different mindsets, different attitudes. It's very important that we have staff that are multi-purpose, so to speak, that are not reluctant to change, that are willing to adopt new practices, that are willing to do not only electrical maintenance but also mechanical maintenance. They need to be broader. And of course, this process is a bit slow, so that the staff that we have in combined cycle plants is younger, and they are a bit more flexible. You must also consider that there has been a decrease, a sharp decrease in output and in the operating hours. And as a result of this, we have had to adapt the maintenance plans to this new scenario. We have wanted to strengthen knowledge in-house, as I mentioned earlier. This is very important for Iberdrola. And Iberdrola is also working hard during the past 3 years in implementing best practices that have been identified globally. The idea is to move towards a global management of our fleet worldwide. I'm referring namely to Spain, the UK, Brazil, and Mexico in terms of thermal generation. And the idea is to standardize procedures, to share and exchange experiences and lessons learned. As for the maintenance strategy, Santiago briefly covered this as well. We're moving towards a hybrid or mixed strategy. We're restructuring maintenance, considering hours of operation and periods of time. In the case of preventive or preventative maintenance, a study has been conducted to replace partly preventive maintenance with predictive maintenance that has been validated by the industry. This has to do with vibration analysis, oil analysis, electric equipment conditions, online plants. And this predictive maintenance is becoming more and more present in our industry, and it helps us reduce maintenance costs. The idea is to reduce the scheduled shutdowns, and this is a direct consequence of the decrease in the hours of operation. So the time between outages is longer now. We follow the criteria set forth by the vendors, namely regarding turbo groups and the scheduling of the major outages. And we see that there is a greater awareness about the need to have that knowledge in-house. It's very important that that technical knowledge is acquired by in-house staff, so that when a vendor is proposing an intervention, we have the knowledge to assess whether that is appropriate or not. And then we have, of course, the new maintenance needs for the conservation and preservation of equipment. It's very important, though, that we maintain the CSAs with the vendors. We need to cooperate strongly with them. It's very important that we follow the recommendations that are born from the experiences of our fleet at a global level. As for in-house staff, we have two departments within thermal generation. We have, on the one hand, the revision and checks equipment or team, that is in charge of conducting maintenance and the overhauls, namely devoted to turbo groups. They provide support at a global level, and either they conduct and execute part of the maintenance during outages, or they do the quality assurance of the vendors, main vendors. And this is a very positive change because it gives us greater control in terms of quality assurance. As you've seen earlier, the issue of revisions and checks is very, very important. They involve a great amount of people. Therefore, it's very important to make sure that there are no human mistakes done or technical errors that can lead to incidents or failures. Then we have the technology department that is more devoted to non-destructive tests, oil analysis, electric equipment tests, on-site inspections, strategies for the longer life cycle of equipment, etc. Earlier, we were talking about operational flexibility, and the combined cycle plants, due to their design, well, we can say that these plants are designed to ensure cyclical operation with very, very high potential, but the market is requesting further flexibility. Also in terms of the startup times. We are carrying out projects aimed at reducing startup times and ensuring greater flexibility in the variation of loads. The idea is to maximize opportunities and the restrictions in reserve markets. These are markets that often request a very, very quick connection to the grid. As for coal, very quickly, I'd like to mention that as in the combined cycle, we've seen the impact, of course, of the decrease in production and operation. But due to the better price of coal as opposed to gas, what we see is that currently the coal plants in many cases are being more competitive than the combined cycle power plants. And this trend will probably change in the near future, but as of now, that's the reality. Some of the oldest plants have been shut down, and that's something related to their remaining life and to environmental issues. And as Pedro has mentioned, these are mature plants with good reliability and availability ratios. And during the past years, the investors are much more interested in other plants that could issue or emit less emissions. All the environmental issues are becoming increasingly important. Here we have a dismantling and decommissioning of a coal plant. As for the global approach that Iberdrola has adopted, Iberdrola has understood that it needs to manage the fleet of turbo generators from a global point of view. Now, let me finish off with some overall conclusions. I have two main messages that I'd like to get across. From the point of view of our business, the impact has been huge in terms of profit and loss statement. Thermal generation has been severely hit by the economic and financial crisis, as other sectors in the industry, but we've been severely hit, no doubt about that. From the technical point of view, the scenario has been perhaps less demanding. We're talking about an intermittent operation. And if we take a look at the indicators in terms of availability and reliability, the indicators have been stable or have even improved because the scenario has been less demanding and the operation has been less intensive. It is true that we are currently waiting to see what the future will bring. Hopefully, we will recover. 2014 is believed to be, well, the end of the crisis. It's going to take some time to take off, and we'll have to wait and see. And probably during the 2020s, we will see that the combined cycle power plants will be once again promoted thanks to a better economic scenario. Probably combined cycle power plants will be more intensively used in combination with other technologies during the 20s. And hopefully we will recover to the levels prior to the crisis. And that's all on my side. Thanks very much.
Y por último vamos a dar paso a Paul Heisman. Él viene en representación de Siemens, así que yo creo que es bueno que tengamos pues, por última ocasión la visión del fabricante, que juega un papel muy importante también.
Okay, we're going to have also a vision now of the manufacturer.
So, hello. Buenos dias. I'm sorry, I would say I'm the only one who have to talk in English, because I'm from Germany, and I would say it's the only way to do it. First introduction of myself, my name is Falk Eisenmann. I work for Siemens in the power and gas services. and therefore I'm responsible for first-time application of new products. So if we develop new stuff, to test it in engines and test it sometimes at customer plans, and therefore I'm most of the time in contact with insurance guys. And due to the fact that I'm working in gas turbine department, my presentation will deal with stuff for gas turbines and combined cycle plants, and deals with what we as a manufacturer do to increase availability or efficiency for the market demands which are coming up, and on the same hand, or on the other hand, to protect the engines and avoid machinery breakdowns. So that's most of the stuff in my presentation. And I will start with a rough overview about our gas turbine fleet. It's separated in two parts. So we have industrial turbines, so it's the smaller ones from 5 to 50 megawatts, and we have large gas turbines, which starts at 100 megawatt and goes up to around about 400 or above 400 megawatt. And for description then, later on I will take one frame out of the portfolio to describe some technical things, what we do to increase the security of the power plants itself. So we have different parts or different styles of turbines. So we have a silo combustor, an annual combustor, and the can combustors. And I choose not the newest one, I choose not the oldest one, I take the one out of the middle. So the annual combustor we have, it's the 4000F. And we start with the engine in 1969 with the first fire of the first engine. And then we develop new products, new materials, and new designs of component to increase the availability, to increase reliability of the fleet, and also to increase efficiency, because the efficiency is one demand for combined cycle power plants, that they could go in operation. And this overview should show what we have done a little bit. I would say it's really much on this one slide, but as we have developed new compressors for the turbines, so compressor mass flow increase, but the main components we have developed are better hot gas pass components like turbine blades and vanes, new burners to increase the firing temperatures, and all this stuff. And in addition, for the European market, because on the European market it's really hard, we need flexibility, and therefore we have developed additional products for grid and peak load, so fast startup products, increased load gradient products, and stuff like this. It's only mentioned here, and the time frame is too short to go in detail on each development. So, and how we do development, that's the main question. We have a process where we take a look at first on the gas turbine side only, writing product requirement specifications, product design specifications, and then create the basic design. And everything for this we do it with an eye on security and to avoid machinery breakdown. And on the other hand, we have the total plant approach. So we look at the total plant, that the product what we develop, or in better material what we develop, and the higher firing temperatures we could run then with a gas turbine, will fit into the whole power plant. So to the boiler, to the steam turbine, and the components behind the gas turbine. And if we have done this, we go to the validation phase and validate our products. Therefore, we have different opportunities to do it. We do a rig test. We have a test facility where we put a whole gas turbine in and test it. And we have combustion test rigs where we could test single burners and combustion chamber parts and stuff like this. And the last one, which we choose sometimes also, is we test a whole engine at the customer site. So go hand in hand with the customer, build a new power plant with a totally new turbine and test it on site. And if we finish this, at the end of the day, we get out of our programs or our development programs a new product or a new design. And this design should help our customers or operators to increase the reliability on the power plants and the efficiency on the plants to get more in operation with the plants. And within this process, we create a lot of patents. It's shown above. So we are not on the first position, but we're on the second one. So GE is a little bit in front of us. And we create some products like an operational flexibility upgrade to increase efficiency, increase availability due to new hot gas components. And we optimize the maintenance stuff like increased maintenance interval with new and better materials. Okay, so on the next slide I will give one example. So I choose a thing out of the annual combustor. So we have installed there ceramic tiles. And the example is out of the combustor, and in what we do to increase the long period creep resistance, that the parts could stay a longer time in the engine and ensure safe operation of the gas turbine or of the turbine itself. And therefore we have some challenges. The picture shows a ceramic heat shield within the combustion chamber, and with the increased temperatures we have to increase the efficiency of the power plant. This increased temperatures could lead to little cracks on these components and will lead to an increased erosion. So the component will be smaller and smaller over the operation time. And therefore, we have developed new materials and new styles. So one new style is the picture in the upper half is the old style, so with a nut included, and we changed the design to a design with a pocket. And thereof, we could reduce the ingestion of hot gas to the metal, to the combustion chamber material, and improve the reliability due to the longer time in the engine. And everything of this is normally done for increased firing temperatures, as I mentioned before. And in addition, we've done also a modification, so we change material mixtures for these ceramic tiles. And with the changed material mixtures, we increase the erosion resistance. And so the part could stay longer in the engine if we stay on the same temperatures, but it could then stay at the same time in engine with higher temperatures. That's the reason why we done this. And the second thing is, at some parts we change totally the material. So we came up from the left picture below, from a metallic heat shield. So we needed to put it out, and then we could maintain and put out the ceramic ones. and we changed this to a ceramic one. It's a totally new design then, and this ceramic one could stay longer in the engine and has a better long-term creep resistance in comparison to the metallic one. That's the main reason. Okay, and the second example I will give is, as mentioned before, the efficiency increases about the firing temperature. And this leads, at the most of the time, to little problems or increased stress on the turbine components. And what we do for turbine components then is we modify cooling air pattern on the blades itself. We improve the cooling air concept for the blades and vanes, that we increase the lifetime of the blades, also to increase the availability of the plant, so we could then go to longer outage intervals with new materials. We developed new bond coats, new thermal bearing coatings, that the blades and vanes could cope with the higher temps. And we optimized castings and platforms and of the base material. So, and that's the one side of the coin, and the other side of the coin is the increased firing temperatures leads to combustion instabilities. And therefore, we have to adapt, on the other hand, burners to increase the flame stability itself, and to put the engine on safe operation at the end of the day. And this will be done, it's only an example here, by a reduce of the swirl in the burner itself, and then we could also twist the burner a little bit, and therefore we increase the flame stability itself, and therefore we increase safe operation and provide the engine before or for trips and shutdowns. Okay, that's a short overview about our fleet. So we have for these 50 Hz and 60 Hz engine, more than 300 engines running in the world, and have a really, really good reliability and availability. And we have an availability in average over, or since 2000, we have calculated this, with more than 59%. The reliability of our engine is, let's say, world class, with more than 99%. And we have also really good starting reliability on this frame, or on the most of our frames, with more than 69%. So the main messages I will give is we have a large growing fleet, not only in this frame, also on other frames, and with excellent operational experience, and therefore reduced risks, because we have a lot of knowledge in our turbines. The second one is we develop new designs, new products to fit on market requirements and ensure safe operation and avoid machinery breakdown for the engines. We develop upgrades and to improve maintenance, to improve performance, and we have, as mentioned before, a really good reliability on our frames. And we validate our product. That's, I would say, it's necessary for an insurance company, that they know that we validate our product before we go to the market. So we tested our products. We tested not only in one engine, so we test our products in some different or with different techniques or tests. And that's it's the last point. So we have future developments ongoing. So we are developing in addition, new bond coats, new coatings, new stuff for increasing the firing temperature and increasing the efficiency of the gas turbines, and therefore also for the combined cycle plants. And that's the last thing. Only to put it in the mind, we have more than 19 years successfully operation with our SGT 4000F gas turbine, so it's really good. And the next year we have the 20th birthday. And that's all from me. I would say thanks for your attention, and I'm here for questions if someone had a question.
Thank you very much. Yo creo que es un buen punto de vista de algo que está tan bien
I think this is a very good viewpoint of something which is very much in fashion, which is innovation. So I think we've got to also see that the front runners in the field of innovation are also manufacturers in this very changing scenario. So I think manufacturers, we've got to acknowledge that the number of patents that we're working with means that some of them are the front runners in the field of innovation. Okay, we are going to try to stick to our schedule and then start a short Q&A session. So I will now give the floor to our speakers, or if somebody would like to break the ice in the audience, please feel free to do it. And for translation purposes, if you do intervene, you need a microphone. Okay, nobody wants to talk because it seems like you're all very hungry. It is almost lunchtime. Okay, I promise we're not going to be too long. But I've seen in all your presentations a common challenge, which is basically cost reduction. So if you want to be in the market, you've got to cut costs down. So I think training and preparation of equipment is very important. And it's been mentioned that now there is a lower investment in the running of the plant. And depending on the technology, training might be very important, and also the maintenance. Because if you give better training, then the maintenance will be done better. I don't know whether this better training, I don't know how this better training is faced by all of you. I don't know whether this was addressed to Danielle. Danielle says, it's not been mentioned much here, but it is very important for this debate that in maintenance costs there's been a reduction, that's evident, and also in investment, especially in whatever is related to the equipment renovation. There's been a high investment. And this has been due to the financial downturn. And this increases the risk related to maintenance and running of a plant. We've got to run and maintain some equipment that might sort of be kind of old, and the risk of failures, when that is the case, is always bigger. And I coincide with Santiago. This doesn't mean that when you try to reduce maintenance, you can do it intelligently and this reduction from liability and fiability point of view do not have a great impact. This is why we talk about predictive maintenance, which is something that in the industry we've been doing for some years now. And I also agree with Santiago when he said that we've got to review and do preventive maintenance. But you do not have to remove a spare part just because the manufacturer says so. Like they say after a certain running hours, you've got to remove them. You better check them out. So I think this is something that we've all reconsidered due to the financial downturn. And when talking about the maintenance staff, we see people who are less and less specialized. If we compare these to the people I used to know when I began working in this industry, there used to be experts, people of a certain age, which were super experts in some fields. We do not have that as much nowadays, and I'm talking at the Iberdrola level, but we do have people who are more polyvalent and more flexible. They are sort of all-road people, and they can sort of perfectly well keep on doing the maintenance of a plant properly, very well. And I think Francisco mentioned that in the case of conventional thermal plants, the running has always been done in a very, very refined way, almost manually in some cases. And nowadays, the combined cycles, everything is more automatized, and the degree of human intervention is much more limited. And of course, in the beginning of the running of these combined cycles, there were many trips. We didn't know why they happened, but with experience and with the years, these trips are less and less frequent, and we know better and better whatever there is behind all these automated systems and control systems, especially when talking about turbines, but, well, in general, of the plants as a whole. My question meant that if you move from running hours of maintenance to a maintenance rather focused on prediction, do you think we've reached this shift? Do you think the sector can sort of tackle that kind of new approach to maintenance? Well, he answers not overnight, but I think if we propose the companies to do so, I think they could go for it. But do we have the knowledge to do that? Yes, he answers. Part of the running staff has to go through a sort of recycling session. We see some reluctancy on behalf of some of the staff that rather want to be specialists, and they like to be as the runners or the sort of the people who are the operators of maintenance. I don't know whether you understand this. These are sort of like the people who are there at the maintenance department, but whenever they have a problem, the only thing they have to know is the number of the person that they've got to call to sort it out. So that's why I call them sort of maintenance operators, as like telephone operators. So, I mean, to really do predictive maintenance, to cut down on outsourcing, we have to give a better training to the staff. Am I aware that efforts are being undertaken to improve that training? I would say no. Maybe in some 6 months' time, we will be ready to do it if we start now with the training. Yes, the chairman says, yes, things do not happen overnight. You've got to sort of program them. Microphone, please. Sorry, we cannot translate. We cannot hear her. It is ridiculous, he says. A valve is more expensive than considering the training needs. When you do training, the more expensive part is having 8 people there following the training, not paying the teacher. That's 80% of a training session. It is not the teacher or the company that gives the training that you pay. That's not your real cost. It's like 8 people there sitting down, paying attention to the training. But that is also like a golden chance for us to improve the running of our plant. If you want a figure, with 50,000 euros, which is the price of a spare part for a valve, with that, an average plant could pay all their needs of training to have a very polyvalent staff and cut down on outsourcing. Perfectly well, they could do it.
Joder, pues es penosa. O sea, por decirla,
well, it will be awful.
Lo que me parece es que el mercado chino, si quiere estar a la vanguardia, tiene que mejorar.
I think if you want to be a front runner, because market is not very much based on cost, and it is asking for a drop in price. And especially engineering companies are just buying things according to price only. And I think we cannot go on for a long time with this situation. I don't know what sort of comments you've heard about the Chinese regulation valves or some of the Turkish piping. They're very bad quality, and that is causing lots of trouble. I don't know, I've been so shocked by Pedro's presentation. I am not able to put through really what the failure of this Chinese spare parts means in terms of money. But I think your question is very important. I think the Chinese spare parts nowadays, in some parts of the areas of power plant, are things to avoid. In some spare parts, sort of, if you are dealing with the spare parts, I think the word Chinese is something you absolutely want to avoid, and we hope there are not Chinese people in this room.
Una última pregunta porque tenemos.
Last question.
Un aspecto en este sector en concreto que me parece muy relevante y es el escaso número de proveedores de fabricantes.
There are few suppliers, and that means that they act as almost as a one single company. And I mean, when you want to develop a field, you always need competition. But here we're talking of a very monopolistic situation. I don't know, well, Siemens might have their own opinion, the Siemens people, but the number of experts in technology, they sort of cover 90% of the offer an operator might find. Because sometimes they are such an oligopoly that really it is not the technical aspects which are taken into account. Okay, he translates himself.
You can see from the different viewpoints the effect of that two only global manufacturers that are providing technology. And normally in the evolution we can see that the competition, that it's the main cause for the improving, and that's the same competition between a big number of providers. In this sector, you can see only two big providers, probably Siemens and GE, and how it can affect in the long term about the possibility of improving and reducing some problems, because in the end, it is strange. Probably in the air manufacturing, for instance, the aircraft, you can see more similar to big Boeing or Airbus, but probably there are a lot of them, small, medium size. But I don't know exactly how can affect in this kind of business.
It's a really good question. But we, at the moment, are not only affected by GE, we are also affected by other companies which do development, or pirates which go to our power plants. And therefore, we as a company develop also, or most of the time, the new products to get an advantage out of the product for the customer, not an advantage for us. So it's an advantage to let the parts longer in the turbine, and I would say the same thing is GE doing. So at the end of the day, it's like a running. So GE runs, we run back. We are on the front. GE runs back to the front. So at the moment, it's like a running.
So the competition is on place.
The competition at the moment is totally on price and or on price and efficiency and power, and that's.
Bueno, yo por dar una puntualización a lo que acabo de decir, yo no sé si el efecto de la.
I don't know whether the effect of this competition that you've mentioned is there or not, because once you buy something, then you are sort of one of these customers or clients that are sort of attached to that manufacturers. The manufacturers, they sort of decide what the cause of a failure is, and they sort of make you be their captured. They really want you to be their customer, but that they don't sort of pay attention to you. They don't sort of treat you very well. And I think we used to have like 3 main manufacturers, and now there are only 2. One is Mitsubishi, which is very small in comparison to Siemens or General Electric, e.g. This is why now the market, I think, is quite complex, and it's very much oriented or biased according to price. But what I agree is that company like utilities, big utilities like Endesa and Iberdrola, they've got a big power in relation to those manufacturers, and they should put pressure on them. They should request them to give them the passwords, and they should also try to develop their own technologies and ways to define some of the failures or to detect some of the failures. Well, in conventional thermal plants, it was similar, and now this is going to be the case also in combined plants. This is a process. Once you buy the machine and you start it up, you start with this very sort of integral maintenance contract where you are sort of, I don't know, kind of hijacked by the manufacturer and the technicians. But in the maintenance of the turbo groups, now at Iberdrola we have people who are specialized and they can do that maintenance. That doesn't mean that in a certain moment of time you have to maybe talk to the manufacturer. We still have that support on their behalf. But I think we feel really captive when we talk about spare parts. And I think there are also manufacturers, they know they're making a big business. It's a big business, spare parts. And there's also sort of another market, an alternative market. But there you start this debate about what spare parts are not critical and you can buy in a sort of second-class market and buy half price your spare parts, but maybe the spare parts might not be of the same quality as the manufacturer's quality, and that's when you talk about these kind of Chinese products and so. But that is what's going on in the States now. There are some companies who are very well experienced, and they might provide you spare parts for your steam turbines, which are a good alternative to the original ones made by the manufacturers. Maybe we at Iberdrola, we've not gone that way yet, but talking about the service, about the maintenance itself, we've begun to sort of take a step forward. And now we have people who are specialized and they are able to somehow debate with the experts and see whether some maintenance actions are necessary or not. But this doesn't happen overnight. This takes some time. And as I've mentioned, we've got some people who are really experts for some maybe 7 or 8 years in the gas turbine maintenance. And now they've got the experience and they can sit with the technician, with the expert, and sort of talk with them at the same level. But it takes some time. I just wanted to say that that sort of alternative market for spare parts cannot be considered until the the period of the guarantee hasn't expired. So how long is that period? The warranty period, the warrant period. Well, it depends. This is related to the service contract. In our particular case, as a result of the downturn, we've been re-bargaining, we've been renegotiating these kind of contracts. And we've been sort of readapting them to our situation. So you might end up also in the alternative market, but so far we're not doing that at Iberdrola. We haven't reached that point. But we might get there. This could be endless, but I think it is better to spend some time in front of a good glass of wine and a good piece of meat.